Hello from Chem Help ASAP. Let's see some more sample diazonium ion questions. Our intended product is on the left. We have a ring with a ketone and an alcohol with meta positioning. The only way to add the alcohol is through a diazonium ion. So let's first add the ketone through a Friedel-Crafts acylation with acetyl chloride. There is the ketone. We can then nitrate the ring. And the nitro group will go to the meta position. I'll combine some steps here. We can, 1, reduce the nitro to the aniline, and 2, form the diazonium ion. We can then warm the diazonium ion in water, and it may or may not require a little bit of heat. To get the alcohol, a phenol. In theory, it may be possible to do the nitration and then do the Friedel-Crafts acylation. In general, however, nitrobenzene is very strongly deactivated and resists further electrophilic aromatic substitution. So in a new problem, again, our desired product is on the left. We have to put a methyl and chloro ortho to each other. This is the challenge. If we put the methyl on first, then the chloro will go para. If the chloro goes first, then the methyl will go para. How can we force an electrophile into the ortho position? We can't. Our only option is to block the para position so that the group will be forced to go ortho. Let's see how diazonium chemistry can help us out. I've already put the methyl group on the ring. The next group will go para. Fine. Let's stick a nitro group in the para position. Okay, the next group will now go ortho to the methyl group. Perfect. Let's do the chlorination. Everything looks good. We need to get rid of the nitro group. The nitro has blocked this position, but we've got to get rid of the evidence. No problem. We can reduce, and let's combine a couple steps here. Let's reduce the nitro group and form the diazonium. Everything is still in place, except we have the diazonium on the bottom of the ring. From here, we can replace the diazonium with H3PO2 and put a hydrogen in its place. We don't need to write in the hydrogen, but I will, just to make it explicit. So, now that we're finished, the evidence that we blocked the para position with the nitro group is gone. It looks like we somehow forced a group to the ortho position instead of the para position. This reduction reaction with H3PO2 is a very handy reaction for certain aromatic synthesis problems. With this video and the previous one, you've now seen the most common types of problems that students normally address with diazonium ion chemistry.